Well, thank you all for coming out. It's the weather today. I was going to make a joke about it, but I think we've all said the same joke. It's like the ice age hasn't left yet. A definition of a glacier is snow that doesn't melt over the summer and more snow starts piling up on it. I don't think we're going to quite achieve that in Verona, but maybe up north they'll have that starting this year. So I'm going to give you a quick disclaimer. I am a family physician, or I was. I retired a couple of years ago. I am not a geologist, and I actually never took a course in geology in college or high school or anything like that. This is all self-taught. And so if people are interested, you can learn this stuff too. Geology sometimes seems a bit arcane to people or difficult, but it's pretty easily appreciable in the sense of just like any other natural history. You can learn about birds and bees and flowers and stuff without having to be a biologist. So, that button. There we go. So we're going to talk about glaciers and big animals. That's a woolly mammoth. The glaciers we're talking about are not this kind of glacier. These are alpine glaciers. These are the ones that we're all learning about are retreating and melting back like in Glacier National Park. We're going to be talking about continental glaciers that came down from the North Pole and covered everything. And why are we talking about it in relation to Verona? I put a quote around this, and there was a speaker at the Verona Library last month in association with their mammoth bones and the big bones that were there. I don't remember the guy's name, and I'm not sure I exactly got the quote right, but it's more or less he said this. Wisconsin's a hot spot for learning about glacial geology, and Verona is ground zero to experience the remnants of the last glaciation. So how many people have lived here for like 30 years or more? I bet a lot of you. How about 50 years? Some of you, all right. Nobody in the 10,000 years, but you guys have all, the stuff I'm going to be showing you, I'm sure you've driven by, played on when you were kids. Your kids have played on stuff, and you've never realized that you're, what it is that you're playing on. You're just sort of thinking of it as grass and ground and trees. So we're going to talk about 6 things today. The first thing is the Pleistocene, and I'll explain what that is, where it was, when, and why. The Ice Age in Wisconsin. Verona, a little taste of what did the Ice Age look like when it was here in Verona. Then what happened after the ice melted? Mammals, vegetation, humans. That's where we'll hear about big mammoths and beavers and stuff. The Ice Age National Scenic Trail, what it is and where is it in Verona. So hopefully when the weather clears up, you'll go out hiking on it. And then what you can see when you go hiking on the Ice Age Trail or just driving around the city. So what's the Pleistocene period? This is going to be the answer to Jesse's question. The last 2.6 million years of the geologic timescale is known as the Pleistocene. It's the most recent big epoch of the geology timescale. In the last 12,000 years ago, since the glaciers melted back, so Jesse's answer would be 10,000 years, but...
You wrote that, I got that from your thing.
Oh, did you? All right, 10,000, well, people debate. Some people think it was 15,000. Nobody was here then, so who knows. But anyway, it's 10 to 15,000, not 100,000, not a million. The Pleistocene is characterized by many advances and retreats of continental glaciers. So it isn't like there was just one ice age, the glacier came down and they retreated. It happened many, many, many times. In fact, could have happened over the entire history of the planet. We just don't know much more than about the last million years or so, because the ice doesn't leave that much around. And we're clearly in an interglacial time right now. There's no ice age going on. But the fact that it's inter means like there might be another one coming, and I'll explain that in a second. So here's the geologic time scale. I just photographed this out of a book. Let's see, I can use my pointer. So the Holocene, the period we're in right now, is this says 11,700 years. So there's obviously some debate. The Pleistocene here is the 2.6 million years. What's all this stuff is sort of the question. So I have a nice analogy for that, and I have to get a piece of paper out here. I came up with this at the dining room table a couple days ago. So if 1 inch equals 1,000 years, so that's more or less the about this big, 12,000 years is a foot. So that's, like from my head to my hand. I'm holding too many things. So that's basically the time at which the glaciers melted back. The Pleistocene, if you use that analogy or that scale, would be 216 feet away. So this building is about 50 feet across. I was looking at it while Jesse was talking. It'd be 4 times the width of this room. That's the size of the Pleistocene. So 1 inch for 1,000, 1 foot for the glaciers, and then the whole Pleistocene is 216 feet. A mile away would be when the dinosaurs died, 65 million years ago when the comet came down and blasted them off the Earth. If you wanted to go, what's the age of the Earth, you'd have to go all the way to Milwaukee. That's 70 miles away. So from 1 inch, now you're in Milwaukee. And Rick, my friend, asked me, well, what's the age of the universe? And we think it's 13.5 billion years old, give or take a billion. So that's more or less 3 or 4 times from Milwaukee, maybe Detroit, yeah, or halfway to Toledo, if you want to go that far. So we're going to be talking about the last foot of that, not all the way to Milwaukee. So what was the Pleistocene glaciation? There are many, many pictures of this, and some of them are shown from the top of the Earth down. This one is the more normal way to sort of look at the surface of the Earth, and this shows the extent of the glaciers in the northern hemisphere anyway. So this line going across the northern United States, through northern Europe, across Russia, and all the way around, kind of like this. Because the Earth was real cold, all the mountainous regions also got extra ice on them, in Alaska and the Alps and stuff, but those were all alpine glaciers. The big continental ice sheets came down from the North Pole. What about in North America? Again, this is just, oops, pushing the wrong button. So here's the medium shade gray is the extent of ice in North America. And this shows it at 20,000 years ago, which is thought to be when the ice was at its maximum. As it melted back, this is 11,000, this is 7,000, just these little islands of ice left. And now, of course, in the current time, it's really just Greenland is all that's left. It's covered with ice. For now, yeah. And that's a good transition to what's going to happen in the future. Well, we don't really know, but we know what happened in the past. And we know from ice cores and sediment cores in the ocean. This is a deep sea sediment core study looking at oxygen-16 versus oxygen-18. They're different isotopes. Normally it's oxygen-16. I don't remember the science behind why you get oxygen-18 when it's cooler, but you do. And maybe someone can explain that. Pressure?
Pressure.
Oh. Pressure.
Yes, the pressure of the Earth pressing against it will cause isotope formation.
All right. That's my wife. Thank you, honey. All right, so anyway, when there's more oxygen-18 and less oxygen-16, you get cool times. So they've basically looked at these deep-sea sediment cores and gone back and shown that there's a cyclic variation to this. This is, here's 100,000 years ago. If you look at this peak, that's about 20,000 years ago when the glaciers were at their maximum. And that's confirmed by looking at deep sea sediment cores. And then when you look at them going back further, they can go all the way back to 800,000 years ago. You can see that it looks like there were a lot of glaciers over the last 800,000 years, maybe 10 of them, so every 80,000 to 100,000 years or so. Where are we currently? We're here, and so we're in a warm period between glaciers. Now, did this go back even further? Nobody really knows. Another way to look at it is the CO2 record. This is from air bubbles trapped in ice cores. And believe it or not, they can measure the CO2 content of that and see what that's been. This scale goes the other direction. So here's the present is over on the right. 800,000 years ago is over on the left. But it's basically the same pattern. Warm times, cold times. Or this is warm times is up here, cold times is down here. So glacial maximum about 20,000 years ago. Currently, it's warmer. Now, where are we in the CO2 count? Everybody knows that for global warming. Does anyone remember what's the current CO2 count now? Well, there's this organization called, I think it's 320.org, where they were trying to prevent the CO2 count from going above that. That happened a long time ago. We're already up around 350 or 380. People are assuming it's going to go up to 400. So, 400 is way up here. So one of the things people talk about is, are we going to have another ice age or not? We probably should, according to the cycles that have been repeated, but human intervention has pushed the CO2 level so high, we are charting new territory here. What causes glaciation? Now, I'm not going to explain this too much, but it's the Russians, basically. See this guy Milankovitch? No, he was a Serbian. Serbia is nowhere near Russia. It's in the Balkans, where the Balkan War was and stuff. And I'm not going to try to explain this at all, because this is astronomy, but it has to do with the Earth going around the sun. The Earth is like a big spinning top, and anybody who's playing with the top knows that it doesn't spin regularly. It sort of twists and falls over and precesses and has all sorts of unusual motions, and so the Earth does that over long periods of time. This is, again, kilo years, or 100,000 years, so 100,000, more or less back to 800,000. So this is the present, and this is that same cycle that I showed you with the other graphs, and this is the future. So the Earth is not going to stop spinning the way that it spins right now. And these are all the different aspects of how the Earth spins. It results in this line, which is changing the amount of sunlight that falls above 65 degrees or in the Arctic. And you can see that this graph goes up and down a lot, and it's not going to change. Right now, for some reason, it's sort of a lull in terms of the variation, but you can expect 100,000 years from now or 200,000 years from now, there's going to be the exact same change in the way the sunlight falls on the planet. So are we going to have a glacial period in 100,000 years? None of us knows. We won't be around here to appreciate it. All right, so that's enough about the Pleistocene. What happened in Wisconsin? So this is that same glacier that came down from the North Pole. This is how far it got in Wisconsin. And I apologize for the graphics. I was telling Jesse, I haven't used PowerPoint for like 15 years. My computer's all out of date. I had to borrow my wife's newer computer and learn how to use the newer version of PowerPoint. And you notice my graphics get better and better as we go along, because I was sort of learning as I went. This is just a photograph from a book. So there were basically 5 lobes of the Wisconsin Glacier that came down and settled onto our state. The main one that we're going to talk about is this Green Bay lobe, and it's so named because it came down through the trough of Green Bay. Horicon Marsh is right in here, and it was this big piece of ice that came down. There was one that came down Lake Michigan too, like here. And then shorter ones, Wisconsin Valley, the upper area of the Wisconsin River, the Chippewa lobe, and then the Lake Superior lobe. This area of the state is called, anybody remember? Duncan? The driftless area, yeah. And why is it driftless? It's because the glacier never reached that. Why do we have the name drift attached to it? Do you get my drift? Don't worry, I'm going to answer that. So it's a funny name. We all are so used to saying it, but it's like, why would they call it that? In the center of the state, this big area, which is not part of the driftless zone, that was actually a big lake in glacial times called Lake Wisconsin, or Glacial Lake Wisconsin, that formed and drained many times at the edge of the glacier. And we're going to talk more about proglacial lakes, or lakes that form in front of the glacier, in a second. We had one here in Verona, I think. So why is it called the Wisconsin glaciation? Well, prior to the 19th century, before the 1800s, most people generally accepted the Bible, at least people in Europe and America, and Christians. The Bible explained how the world was created in Genesis. Noah's flood was part of the Bible, and it explained how water covered the surface of the earth and washed across everything, and Noah saved all the animals in the ark and all that kind of stuff. This sort of made sense when geologists started roaming around the planet, One of the things that happened in America, and I think in Europe too, is people started digging canals and connecting all the great river systems together to get boat traffic into the interior. So the Erie Canal and the Ohio Canal and many, many other canals were dug at this time. People looked at the earth as they dug up these canals, and they came to realize that the kind of rock that they dug up in the Erie Canal in northern New York was similar to rock that they would find in Ohio and then in Wisconsin. And they began to get this sense of a huge sedimentary shield that was across the middle of the country. That made sense to everybody because if you had a flood, you could see when water flooded areas, it would wash sand and stuff across it, and you get these layers of stuff that, now how they explained it all, I'm not exactly sure, but one thing that they noticed was they're called erratic boulders. So there were many, many rounded boulders. These were all found north of the line that I showed you where the glacier stopped. So they didn't know anything about glaciers at this time, but they knew the boulders had an edge to them. Like below that line, you wouldn't find these boulders. Above that line, they were all over the place, and especially a lot of them right at the edge of the line. And they were called erratic boulders. They were made of granite. They weren't of rock from around here. They were strange-looking rocks, and nobody had a really good explanation for them. What they came up with is that these were kind of like driftwood that you'd find on the edge of the ocean. They must have drifted in on Noah's flood and been left there. Now I'm going to ask Duncan, since you're right in front of me, what is the problem with that explanation? Why wouldn't Noah's flood have washed in all these giant boulders? Some of them are like the size of a school bus.
Because the rock would probably be a little too heavy for the water to carry that.
Right. There you go. So rocks don't float. And nobody seemed to have figured this out. Like that didn't seem to bother anybody. It's just like they thought, well, the rocks must have floated. So, but this bothered the geologists and the scientists because they were smart enough, they realized that. So how did they figure this out? In the 1840s, this is around the time when Charles Darwin was doing his work and explaining that the Earth was actually a bit older than we thought it was in Genesis. Geologists were working mainly in the Alps area. They were studying glaciers. There was a guy named Louis Agassiz, which I think is a great name. He later became a professor at Harvard and wrote books. Louis Agassiz and the Swiss geologists, they were studying ice in the Alps. And you know, rock climbing got to be big, and they saw these same boulders at the base of glaciers in the Alps, and they began to think maybe liquid water didn't bring them down, maybe it was frozen water. And little by little, they put together this whole theory that there must have been huge ice sheets that came down from the North Pole. Well, they were just laughed at essentially at the beginning, like ice covering the whole planet. That's ridiculous. You know, we don't see any evidence of that now. But more and more, it became to be accepted. In the 1880s, there was a guy named Chamberlain, T.C. Chamberlain, a University of Wisconsin geologist who later became the president of the University of Wisconsin. He studied glacial geology, and he studied it in Wisconsin, where evidence of glaciers was abundant if you only knew what to look for. And he did, and he looked for it and found it, and wrote this 4-volume bestseller called Geology of Wisconsin. I'm sure that one was hot off the presses and stuff. And so it was so influential in the scientific world that last glaciation, which left all of this evidence, became called the Wisconsin glaciation. So everybody in North America knows it as that. In the Alps and in Europe, they didn't really kind of buy that. They called it the Würm glaciation. In Northern Europe, it was the Weichselian, and in England, the Devonsian. So what the US called it didn't matter that much. So if you ever read terms, should you be browsing in books like I was or reading Wikipedia, all of these terms are the same glacier. It's basically Wisconsin Glacier here, the Würm Glacier if you're in the Alps. So there's Mr. Chamberlain himself. You could really date that from the 1880s, couldn't you? That's just a James Garfield kind of beard. And here's the boulder at the University of Wisconsin that's named the Chamberlain Boulder. That's the UW Observatory, or Washburn Observatory in the background. This boulder sits up on top of Bascom Hill, which is a huge glacial remnant itself. It's called a drumlin. I'm not going to talk much about them because there's no drumlins in Verona, but the Bascom Hall or Bascom Hill and the Capitol building both sit up on top of glacial remnants or large hills. And this boulder, I think, is sitting right where it ended up. I don't believe it was moved, not very much anyway. So let's then talk more about Dane County. So this picture reviews what we were talking about. This was the huge ice sheet that came down from the North Pole, the Laurentide ice sheet. This is what it looked like in Wisconsin with all those different lobes. This one puts another lobe in called the Langlade lobe instead of the Wisconsin Valley. Some people combine those two together. But anyway, here's little Dane County. I don't know if you can see that in the back, but Dane County's at the bottom. And the reason Dane County is interesting is, if you look at it, we're basically a rectangle, and half of the county was covered by the glacier, half of it wasn't. And so we're right on the edge of that, and that's why we're a hot spot. What did Dane County look like particularly? This is a geologic map of Dane County. I got actually handed this at a committee that I'm on for the town of Verona when we were talking about the town of Verona comprehensive plan. And I said, hey, that's a really cool map. I like that. If you look at it, there's basically sort of three parts to the geology, the surface geology in Dane County. It's this light green, then the darker green, and then this part. And you don't have to be a scientist to say, gee, that looks really different. Something is going on here, and it looks like there's these striations or channels that all kind of spread out like this. And then here it's kind of a jumbled mess. And then here there's this sort of regular pattern again. So this is basically the glacier came down this direction. It ended right here and left all this debris and junk. And then this is all the driftless area or all the hill and valley area that didn't have any glacier on it. So that should be pretty clear. You don't need to be a scientist, just maybe appreciate art to see that. Here's the three regions identified. The Drumlin zone is this this area here, which is covered with all these elliptical shaped hills. We're in the hummocky till zone here, and then there's the driftless area is just out west of us. So in Verona, what did the ice age look like here? And I think the next picture is a zoomed in view of that last map where I added a text box. See, I figured out how to do this on PowerPoint. Nice, huh? This is halfway through the talk. I figured, hey, I can write on this. Wait. So this is Verona right here, and we're sitting, at the senior centers that are right about in this area somewhere. This is Badger Mill Creek. This is the quarry out by Epic, sits right in here. There's little lakes. Here's Morse Pond up by the UW golf course and the 5 Points area where the house is that we're going to take a tour of in 2 months. And then, of course, this is the Sugar River Valley down here. If you want to know, the light green is basically till from the glacier or dirt that was dug up by the glacier. The red stuff is outwash. As the glacier melted, it flushed a lot of this debris out. And then, the blue is leftover lakes and water and wetlands. So what did the glacier look like in Verona? The glacier's edge hung right across the downtown area, right along Shady Oak Lane, running along County M by Wayland Road, and in Prairie Moraine Park. The ice edge was probably at about a 30-degree angle. When I talk to people about this, I just say if you put your hand up at like a Heil Hitler kind of salute, or that's about the angle that the glacier was at. And so if you would have been here 15,000 or 20,000 years ago, and you had ropes and ice axes and crampons and said, I'm going to climb that thing, that would be a pretty tough climb because you're climbing up ice at about that angle. How far up would you have to go? Well, on the edge of the glacier, it came down to 0 feet high, but pretty quickly on the edge, it was so steep, you'd be up 100, 200 feet in no time. If you got up on top of it and headed for the North Pole, once you got to Madison, the ice was about 500 feet thick. And I looked it up, the Capitol's 284 feet tall, so this was more or less twice the height of the Capitol. If you kept going and said, I want to go see what Green Bay looks like, because we're on the Green Bay Lobe, you could head up to Lambeau Field. The ice was at least a half a mile thick, maybe a mile, as much as a mile thick. And at the most, back up in Canada, it was 2 miles thick, so that's 10,000 feet, which is many times the height of the Capitol. You know, two miles is a lot. When the ice melted, it didn't retreat or go backwards, it just melted in place. So how did the ice get here? If you've ever poured peanut butter or put peanut butter on your kitchen counter, and just let it, like, especially if you take it out of the refrigerator, you put a big scoop of it and just leave it there and sort of let it warm up a little bit, it will very, very gradually sort of spread out and eventually kind of cover a lot of the counter. It'd be a big mess, and I'm not allowed to do that at my house, but that's more or less how the ice flowed. It's a plastic flow, and it's very, very slow, flowing outward from the highest point. So the highest points are at these centers up in Canada, and it just flowed out in all directions from there. When it melted, it didn't go backwards. It just melted in place. So all of the ice that formed this 2 miles thick of ice, it turned into water. It all had to go somewhere, and that's what we're basically seeing left around is after the ice melted, all the stuff that was in it and all the water that washed out, washed things everywhere. So this is a drone picture. Jesse showed you some drone flying over Verona. This is a drone showing what the glacier looked like in Verona. They actually had drones too, 20,000. No, I'm just kidding. This is a view of a glacier, the Burroughs Glacier in southeastern Alaska. And I saw this in a book, and I said, you know, that looks pretty much exactly like Verona probably looked 20,000 years ago. So Verona would have been like right about here. This is basically draped right across downtown in Verona. The glacier is obviously very steep. That's the 30-foot angle or 30-degree angle, or maybe more like 45 at this face. And then all of the water that's melting off of it, this is the Sugar River Valley, essentially. It's, you know, covered with glacial outwash. If you look at the glacier, my wife wanted me to say this. She went to Iceland recently with our daughter and said, actually, how many of you have ever seen a glacier, like been to Glacier Bay or something like that? So, is it white or blue? Yeah, so the stuff you see melting out and calving into the water, that's blue. If you've ever flown over one or gotten on the edge of these continental glaciers, they're actually brown. They're full of dirt and rocks and debris and stuff that they've bulldozed ahead of them. And I think this picture shows it pretty well. This is ice, but it looks like, you know, it's not clear. And then all of this brown stuff, and there's lines in here, that's all dirt and rocks and debris that are all part of the melting out glacier. All right, so after we're going to go back to that and talk more about Verona in particular, but this is a little digression now because everybody wants to see pictures of mammoths and stuff. After the glacier melted out, what did things look like here? So I showed you this picture before. The ice melted slowly over about 10,000 years. And it started here 20,000 years ago. By 11,500, it was thought to be here. By 7,000 years ago, it was here. And so as the ice melted backwards, the land opened up. This is that famous Bering Sea land bridge and the path that humans maybe took down to get into the North America. Vegetation changes. So what did the land look like, or the trees and grass and stuff? 18,000 years ago. This is from lake sediment cores, like basically sticking a big pipe down into a bog and going down as far as you can drill the pipe down and pulling up sediment cores. And what do you find in terms of pollen? About, for the first 8 or 10,000 years, it was a big spruce forest. If anyone's been up in northern Canada, the taiga forest, it's all black spruce, or they're called drunken spruce because the ground is still partly frozen. The trees are tilted at angles. They're small trees. And that was what the ground looked like here, or the land looked like, is like northern Canada looks like now. As the climate warmed, ash trees came in, birch trees, pine, and elm. And it wasn't until about 10,000 years ago that what we now associate with southern Wisconsin, at least, came in. So the oak trees and oak savannas are something that was just here in the last 10,000 years or so. This was from Hook Lake in Dane County, which I'm not sure where that is, but somewhere. So this is essentially what Dane County looked like over the last 10,000 years. And there's actually a photograph. This is from, no, I'm just kidding. Another drone picture. This is a painting to commemorate the Battle of Wisconsin Heights, which was in 1846 or something like that. When we, huh?
32.
32, okay, thank you. We drove the Indians away from, Black Hawk and his band of women and children. We drove them away, and then an artist was assigned, I think 25 years later, so it would have been right after the Civil War, to paint a picture to commemorate this. So that's Wisconsin Heights right there. In the background, this is the Wisconsin River Valley. There's two little towns that are shown here. That's Prairie du Sac and Sauk Prairie, before they kind of merged into one. That's Gibraltar Rock right there. And in the foreground is the Oak Savanna of Wisconsin. So, and this is the Baraboo Range back here. So in my mind, this is actually one of the best evidences of what Wisconsin looked like, at the time of settlement. It was all oak savannas and open prairies and stuff. What were the animals that were here? They were not here at that time, but this is thought to be the kind of animals that roamed the ground, artists' rendition of it. Mammoths and mastodons are the iconic Ice Age animals. Does anyone know which is which? Duncan, you want to take a guess? Well, the mastodon is the little one on the right. The mammoth is the one on the big one on the left. Mammoths are forebears of our current elephants. Mastodons branched off a long, long time ago in the genetic world and are really different and then died out. They were identified by the kind of teeth they had. Mastodons ate wood mostly and had sharp, pointy teeth. The mammoths look more like current elephant teeth. They chewed on grass. And the word mastodon actually means breast teeth. So masto, like mastitis or whatever. Somebody, I think it was a French guy, thought these looked like breasts. We had giant beavers when the glacier first melted out. There were lots and lots of ponds and lakes. Beavers back then, like all the other animals in the Pleistocene, were huge, and so that was a 9 foot tall, a 9 foot long beaver compared to a modern beaver here. There's a museum along the Ice Age Trail in eastern Wisconsin that actually has comparisons of beaver skulls. There's the ancient beaver, here's a modern beaver. So I'd be afraid of those kind of beavers. There were camels roaming North America, mostly in the western area. We don't have any evidence of them in Wisconsin, but there were lions, American lions. There were all sorts of ungulates. There were also tigers. So the saber-toothed tiger, if anyone went to the Verona Library exhibit, they had a saber-toothed tiger skull there with the giant teeth. They call them scimitar cats, but saber-toothed tiger is more of the current name. And then their back legs look like rabbit legs. They could actually crouch and then spring off of a rock, and they were thought to be able to jump 20 feet, even though they weighed several hundred pounds. So you can imagine if you were some poor antelope walking along, and then suddenly that guy jumped on you. Life was short and brutish back then. And then if you ever have seen the Hollywood version, this is what the animals look like. But that actually shows the spruce forests that were here. All right, how about humans? How did they get here? I showed you as the ice melted back, it's thought that a big corridor opened up. When most of the Earth's water was in ice, the sea level was much lower, and so there was a land bridge across the Bering Sea. Hardy humans came down through there and then populated North America. There are other suspected ways they got here because we've actually found evidence of humans being here even longer ago than the ice opened up, and that's been perplexing to people, so they realized maybe they came by water instead. And so there's these other migration routes where they come down around the ice. What did the humans look like? Well, of course, nobody really knows, but this is an artist's rendition of them killing a woolly mammoth. I find this charming because these guys have bare legs. Basically, they're out in a blizzard throwing spears at a mammoth, but they're only sort of partially clad. And I just don't think that would have worked. Here's another version. This could be, that's the glacier in Verona right behind you there. There's the lake in front of it. This is just south of Verona, down in the Sugar River Valley. They got a mammoth trapped, and they're, all these guys, again, they're all partially clad. I don't know why they don't wear any clothes, but they're stoning and spearing this mammoth. This is a picture that's in the Arboretum. If you've ever been to the Arboretum, they have a little room that shows like what the land used to be like. There's actually a big smiling face painted into the glacier up here that I cut out of the picture. And then here's the Ice Age version of how people shopping at Miller's. So once they killed one of these mammoths, they would butcher it up, and all the women would come and take a hunk back, and that was, you know, food for the next month, I guess. All right, so enough of that. Let's talk about the Ice Age National Scenic Trail. I'm going to talk a little bit about history and show more old white guys, because this is a historical group. What is the Ice Age Trail? First of all, it's a 1,000-mile-long trail. So people all over Wisconsin know the Ice Age Trail is this trail that's in my backyard, like Jesse was mentioning. You know, I can walk to it from my house. It's really cool. I like the park. I've worked out along it for a number of years, and it's common to meet hikers coming through that are that will say things like, if I keep going in this direction, like, how far do I go? Like, can I get back to my car? Like, is the parking lot up here? And I like to say to them, if you keep going in that direction, you get to Potawatomi State Park up in Door County. And then they sort of get mad. They go, oh, the other direction, the direction I came from, where do I go there? And I say, well, that's Minnesota. So you get to St. Croix Falls. So the Ice Age Trail goes all across the state. Here's the western terminus, it's called, in St. Croix Falls. And this shows the that same picture of the glacier edge. Everything that's in white, that's all these lobes of the glacier that I was talking about. So the Ice Age Trail is this red line that more or less follows the edge of the glacier. And it starts up in Door County at Potawatomi State Park, goes down through the Kettle Moraines, down to Janesville, takes a big loop, comes back up. Here's Verona and Cross Plains up in here. Goes up to Antigo and then heads west across all of the loops over to St. Croix Falls. It's a member of the National Park Service. It's a National Scenic Trail. Our logo is the woolly mammoth. There's 13 National Scenic Trails. So if you're wondering what's a National Scenic Trail, the Ice Age Trail is one of those. Here it is. It's one of 3 that's in a single state. So there's an Arizona National Scenic Trail, a Florida National Scenic Trail, and then the Ice Age is Wisconsin's National Scenic Trail. The more famous ones are the Pacific Crest Trail, the Continental Divide Trail, and then the granddaddy of them all is the Appalachian Trail here. But we're in that same category, and I think sometimes people in Verona don't realize how special this is, that we've got this resource basically running right through town. I know in some places it doesn't look like a National Scenic Trail because there's not necessarily a ton of money to keep it up and maintain it. It's all done by volunteers, but nevertheless, that's what it is. How old is it? So some people don't realize that the Ice Age Trail is now 60 years old. This is our current logo for this year at least. It was established in 1958. Here's one of the old white guys who founded it. So Ray Zillmer is called the father of the Ice Age Trail, the grandfather of the Ice Age Trail. He was a lawyer in Milwaukee. He liked to go outside. He was in the Isaac Walton Outdoors Club and would go hiking up in the Kettle Moraine area. He understood the glaciation and the Ice Age, and I guess like me wanted to preserve that as much as he could, and so he founded in 1958 something called the Ice Age Park and Trail Foundation. He had this vision that this was going to become a national park. He focused on what's now the Northern Kettle Moraine State Forest, and I think helped to preserve a lot of the land around there. He had this Ice Age National Park idea to commemorate continental glaciation, but unfortunately he was a bit too old to see his dream happen, and he died shortly thereafter. He did manage to pass the dream on, though, to Congressman Henry Royce, who was from the Milwaukee area. And in 1964, I think Congress worked a little bit better back then. They actually passed some legislation that created the Ice Age National Scientific Reserve, which then President Johnson signed and made it part of the National Park System. The original legislation just created 9 Ice Age Scientific Reserve units, and they're still here, and they're shown on this map. St. Croix, Chippewa Moraine. The 3 in this area are Devil's Lake, which is now a state park. In Cross Plains, there's a scientific reserve unit, and then Horicon Marsh is another one. And those are all the ones that are nearest around. At that time, there wasn't any big trail linking them all together. That came later. Here's a picture of Henry Royce talking to Gaylord Nelson, who was the founder of Earth Day and was our governor, and there's a Gaylord Nelson State Park up by Lake Mendota. So in the 1970s, this is now maybe 10 years later, several trails that were along this route were organized and patched together to start forming the Ice Age Trail. Somewhere around 1975, some hardy soul, and his name is known, but I don't remember what it was, actually hiked the entire, what's now the Ice Age Trail. Most of it wasn't organized, there were no yellow blazes, it wasn't marked, there was no GPS back then for him to find his way. I have no idea how long it took. But once the guy had done it, then everyone thought, well, we've really got to make this trail now, like someone's actually hiked it already. So in the late 1970s, the Ice Age Trail joined the National Trails System. President Carter got involved when he signed legislation in 1980 to officially establish the Ice Age National Scenic Trail as part of the National Park Service. And in 2009, the name Ice Age Trail Alliance, which is the official name of the organization that creates, supports, and protects the Ice Age National Scenic Trail, was formed. The headquarters are in Cross Plains. It's the only building in Cross Plains that has a mammoth out in front of it. It's a big metal sculpture, so you can't miss it. It's really growing by leaps and bounds. I was on the board of it for a while, and the organization really is on a roll at this point. And so a lot of people say, well, that Ice Age Trail, that's not done yet, and when's it going to get completed? I don't think it'll be in any of our lifetimes, maybe Duncan's. So it's going to be a long, slow process, but people are working on it. So let's get back to Verona. Where is the Ice Age Trail in Verona? So, hey, yeah, so some people are here in the audience here in this week. Yeah, a little close. Sorry, every time I turn, I lose it. All right, so the Ice Age Trail, here's a map of the Ice Age Trail in Verona. The Verona segment is 7 miles long. It goes from Prairie Moraine Park here at the bottom through the Moraine Kettles Preserve, which I think is where Jesse hiked, if you live in Cathedral Point. Yeah, so that's called the Moraine Kettles Preserve. You cross the 18151 bypass and go into the Badger Mill Creek corridor. Again, cross Military Ridge Trail. This is the park and ride and where the Dane County home used to be, and you enter Badger Prairie Park. Go by Redden Soccer Park, up through Ice Age Junction. This is all a huge restored prairie, thanks to Dane County Parks work. And then that's the official end of the Verona segment right here on PD. It then becomes the Madison segment and goes further north and across County M over to the UW Golf Course. And we actually have a trail going through the UW Golf Course. Right now, this is where they're doing all the construction, road construction. There's going to be a tunnel underneath County M that will carry the Ice Age Trail, probably in about a year when they finish the construction. I think it may be one of the last things they do. And then the road construction that was just done along PD put the big bridge over PD that probably many of you have driven under. That carries the Ice Age Trail too. So if you've driven under that bridge, you've been on that. I've asked several people why we can't have a big sign that says Ice Age National Scenic Trail going across the bridge. And people just say no. And I don't know why. It just seems like that would be a good idea, but so maybe we can all fight for that. 1 year ago, Verona became an official Ice Age Trail community, and so we had Miller's make a cake to commemorate that. There's a big ceremony with Mayor Hockhammer and a number of other people. We all went out and hiked on the trail. All right, so what can you see in the Verona area? This is really what you came here to find out. We're going to talk about 6 different things you can see easily in the Verona area, and I'll try to show you pictures of these. Glacial erratics, we talked about the big boulders. the terminal moraine or the edge of the glacier, kettle ponds, outwash features, proglacial Lake Verona, and the Elver Park Tunnel Channel. So just to remind you, we're going to talk about this map. Let's see. Prairie Moraine Park is down here, where it's right at the edge of the glacier, and it shows you the terminal moraine going through the town. That proglacial lake is up here. Badgerville Creek outwash is coming down through here. The Elver Park Tunnel Channel is this feature. And then the erratics are everywhere. If you know what to look for, you'll see them on your way home today. So what are glacial erratics? Again, they're boulders of non-local origin that were transported by the glaciers from somewhere up north. If you're a geologist, you can look at them and you can actually tell which mountain got scraped off to make this boulder. I can't do that, but I'm in constant admiration of people who can. Mostly these are granite or metamorphic boulders that came from northern Wisconsin, Lake Superior, or as far away as Hudson Bay. 3,000 miles or more to get here. They were rounded because as the ice brought them down, just like gravel coming down in a river, they get rolled around and get rounded off. Because there was a lot of freezing and thawing, some of them have sharp edges on them because they were originally rounded and then water got into the cracks and froze and then broke off half of it. So you see a lot of rounded boulders that are split in half and have sharp faces as a result of that. Here's the glacial erratic in situ at Prairie Moraine County Park. I just took this picture. I'm afraid most of my photographs are from the last week, and they're all gray and brown because that's what it looks like outside right now. Usually it's a lot prettier, but so this boulder has been sitting here probably for 10 or 12,000 years since the ice melted. It rolled down the hill created by the glacier and sat there and hasn't moved since, I'm quite sure. This is the same park that has the leper colony, of course. Here's a boulder train at Prairie Moraine County Park. I work with a group of people who likes to clear brush. We cleared all the brush off of this, and they just said, wow, look at all these glacial erratics. So these are relatively small ones, but yeah, that's the way I thought. Anyway, so they're 2 to 3, 4 feet across. None of these are too huge, but anyone, there's some of my friends from the ICS Trail are sitting at the table back here. If you've ever tried to dig one of these boulders out, you really have no idea what you're getting into. It might just be below the surface, or it might go down 20 feet. And so we have a method of like tapping on them and kicking at them to try to figure out how big they are. And if they're really big looking, like we don't touch them. So here's a homeowner's. This is on Wayland Road. Glacial erratics. Now I think these two probably were on the property. These guys obviously weren't, so these were bought at a local quarry. So probably a lot of you have stone walls like this. I promise you the quarry people didn't make those. Those were all brought down by the glacier. They're from wherever, northern Canada someplace. And then they just accumulate them and sell them to people to make walls out of. Here's another huge glacial erratic. This one's probably 6 feet tall. It's, I think it's Wisconsin red granite, so it's a state rock. It probably was left right there. It's the Augusta property right next to Moraine Kettles. And then they probably tilted it upright to make it, look bigger and stuff. It probably was lying on its side or something like that. Yeah. All right, so so if you look, I'll just go back a second. On your way home, as you're driving through Verona, be careful driving, but look around you and look in people's front yards. I was doing this the other day, and about a third of the houses in Verona have big boulders sitting in their front yard. A lot of them have gardens around them. Some of them are just sitting out. All the parks have boulders because they're big and hard to move, and so people basically just sort of work around them. If you're going to build your house, the bulldozer will push them out of the way, but then you'll probably save it and make a garden around it wherever it ends up. And you'll see them everywhere. If you go down as far as like Belleville or places south of here, you just won't see these, and that's because we're right on the edge of where they were all deposited, unless people went to a quarry and bought them, of course. So now we're going to talk about the End Moraine. Here is a glacier from Greenland that's still active, and this is showing the glacier probably melting back a bit. and then leaving this big pile of dirt. And so when I said glaciers are brown, this is what I'm talking about. They are bringing down huge piles of dirt. This is several miles across, so this is a 5 or 6 mile long moraine. How do moraines form? This is, again, picture the glacier in Verona. This is the 30-degree angle that you were going to climb up. Before you get to the ice, you're actually going to climb up a big pile of dirt that was left by the ice as it came down. And the ice the dirt either comes from the top of the glacier as it washes down, or sometimes as the ice is scraping across the ground, it'll pile up a bunch of dirt below it like a bulldozer blade will. In either case, you get something in this kind of shape that looks like a moraine. It's sort of flatter on the backside of where the ice was, and then, it's flatter where the dirt rolls off, and it's steeper on the ice face. So I switched, I finally learned how to import maps when I was about 2/3 way through the talk. And so I began to use this map, which is basically from Google Earth. It's a terrain map of Verona. And you're going to see this over and over again, so I just familiarize you. The reason I liked it is because it shows all the roads. So here's the 18151 bypass going around Verona. Here's Verona Avenue. Here's Main Street. There's the 5 points with Morse Pond. Here's Prairie Marine Park. So it's the same, more or less the same view. Where was the glacier? If you want to know, like in Verona, that's the edge of the glacier, basically with the streets shown in the background. I think we're right here on Paoli Street. That's Fireman's Park, or the ponds in there, so I think we would be sitting right about there. We're right at the edge of the glacier right now. Where's the terminal moraine? Well, obviously it's the edge of the glacier, so right there. And you can even see this on the terrain map. I didn't draw this line very accurately, so here's Shady Oak Lane that goes up and turns around. I think, Doug Maxwell, you live right up here, don't you? Yeah. So there's Shady Oak, and you can even just see on the terrain map, that's the terminal moraine right there. Prairie Marine Park, the same line is here, so it's basically a line that goes right across Verona, about like that. It's not as well seen in the downtown area because building process has sort of washed it all away. But the other reason is because this was a huge outwash area, so there was actually a break in the moraine where all of this debris came out, where the glacier flooded it all out, and it flattened the area. And so that's when the settlers came in, and the Indians before that with all the mounds that were here. This is a significant area because it wasn't as hilly, and it was more or less the gateway to the driftless zone, which is out here. Here's the Sugar River Valley. So what do you see if you're looking at the terminal moraine? There it is in Prairie Marine Park. So this is the southern end of it in the Verona segment. If you go park there and look up, you'll see that behind you. A better view of it is here from further into the park if you look back at it. It's a hill that's several hundred feet tall. All of that is glacial debris that was dropped off by the ice. So the ice contact face would have been up like this somewhere, about at that kind of angle. And then this is all dirt and rocks and stuff that rolled off of it. This flat area in front of it is about the highest point of the sedimentary rock that was overlain by the glacier. So when you go to Prairie Marine Park, there's actually an outcrop of, I think it's called St. Peter's Sandstone is the highest rock. And you can stand on that, and then you look up several hundred feet and you'll see the moraine behind you. Along County M, this is also pretty inconspicuous, but it's still there. This is the terminal moraine. If you're standing on Wayland Road, where I was when I took the picture, that's the Ice Age Trail running right along it up towards Moraine Kettles, and Prairie Marine Park is way back here. But this is the terminal moraine along County M. It's maybe 100 feet high. When you get to Shady Oak Road, this was a lot harder to take a picture of for me because it's covered by trees and houses. But the reason that these trees all stick up above the horizon, well, as you come around the bend, is that this is the terminal moraine. And it's really quite dramatic if you drive up there. You come around this bend and you'll drive right along this big hill that's to your right. And if homeowners now live up on top of it and behind it, there's a couple of roads that go through. And you have to drive up at a fairly steep angle to get up to where those houses are back on the Moraine. All right, kettle ponds. Where do you see kettle ponds and what are they? These are ponds that form near the edge of the glacier when the melting glacier leaves behind huge blocks of ice. And again, these are like the size of school buses or sometimes 10-story buildings. It's like all of that ice that was here, like I said, didn't go anywhere. It just melted in place. Some of them are acres in size. Kettle lakes can be a mile across. I didn't have a picture of it, but Morse Pond in the Five Points area is a kettle pond. So that's one of the bigger ones in the area that people are more familiar with. These blocks of ice may take thousands of years to melt out. Because the climate didn't suddenly go from ice age to current, the ice melted very, very slowly. There might have been a couple of weeks in the summer when the ice was melting, and the rest of the time it was freezing cold still. So an inch every 100 years would melt off of these big blocks of ice that were left around. And so sometimes it would take hundreds or thousands of years. The ice was full of all sorts of dirt and debris, and as it all melted out, the dirt would slide down the side and form big sides on the block of ice. And so you'll find a hole in the center, and then big mounds on either side, which is where all the dirt ended up. One way to visualize this, I saw a video of this, and I couldn't find it to show you, but if you blow up a balloon and go to a sandbox and dig a hole in the sandbox, stick the balloon in the hole, and then cover it all with sand. And then get a sharp stick or a sharp needle and basically go down through the sand and pop the balloon. You'll suddenly get a big hole that forms where the balloon was. That's basically how kettles are formed. The balloon is the ice instead. So what does this look like in diagram formation? There's the ice sort of embedded in the dirt brought down by the glacier. As it melts out, there's lakes left behind. Here's one in Iceland. It's, did you see this, honey, when you were there? Or? No.
Similar.
Yeah, something similar. Okay. So what I like about this is it says several students are shown for scale. So it's geologist humor about what do you do with students and stuff. Usually they put an axe or a coin or something like that. They always like to have scale on it. But so this is the dirt that was embedded in the ice. This is the ice block still there, and then that's the kettle pond forming around it. What does this look like in Verona? There you go, Moraine Kettles Preserve. And I think this may be the lake you guys walked around. Yeah. Yeah, so it's a huge kettle, yeah. So we've done, Ice Age Trail has done a lot of clearing around this. You used to not even be able to see these lakes back in there. There was so much honeysuckle and buckthorn and brush around it. It was hard to appreciate, and they were full of mosquitoes, and nobody in their right mind would go digging around looking for the kettle pond. So we were able to, we were able to clear all of that away, and now you can see the kettle pond there, and it's beautiful. It's huge and lovely and stuff. There's one at Prairie Marine County Park, or several kettle ponds. These are still harder to see because we haven't finished clearing out around them, but that's the kettle pond. That's 3 or 4 times the size of the one in or in Moraine Kettles. And there's another one just over here, and actually a whole series of them going back up the hill, where blocks of ice melted out right behind the moraine. All right, outwash plains. This is, what is outwash is basically debris left by the melting glacier. It's dirt, sand, gravel, big boulders, all that kind of stuff. The Sugar River Valley is the main outwash plain, and the Badger Mill Creek was a major contributor to it. I'll show you this picture again. This is all outwash in here coming off of that glacier, but that's more or less how the Sugar River Valley formed. 300 feet deep is estimated to be the depth of the gravel in the Sugar River Valley. So all these gravel pits that are down there, they could keep going for a long time. How did this happen? Here's, again, the same picture showing the glacier coming down onto Verona. As it melted back, so now the glacier has melted back to about where PD is, or the edge of Madison. All of this water that came off of it came down Badger Mill Creek. So Little Badger Mill Creek that now you can practically jump across and has been channelized and is like more or less a farm ditch, used to be a roaring river, probably with standing rapids and washing huge boulders and sand and gravel down it, as little as 10,000 years ago or 7,000 years ago. There's a section of it that I like to call the Verona Gorge. It's between the Eastview Heights neighborhood and whatever this neighborhood is called. Here's Lincoln Street is right here, and City Hall, I think, is like right in there. And Miller's is sitting right there. So there's this narrow part of Badger Mill Creek where you can actually see the sides. It's sedimentary rock, kind of like a channel, and all of this water used to go through here and just carved out a huge gorge.
It's kind of where the bridge walk is, right?
Yes, exactly, where Lincoln Street Bridge is, yeah. And the Ice Age Trail, of course, goes right through there. Here's Prairie Moraine County Park. The course of the Ice Age Trail is more or less right up like this. So we have about 1.5 miles of walking through Badger Mill Creek. What did it leave behind? I just got, again, my phone and used Google Maps and said, where are all the quarries, in the southern part of Verona? And I just put a little red oval on top of all the quarries. So you can sort of see the pattern there, I think. This is...
Microphone.
Sorry, microphone, all right. This is Fireman's Park right here, so I have some pictures of this. Here's what's left behind. Here's a gravel pit in Verona. And then here's Fireman's Park, which is a huge gravel quarry and sand quarry that was used up by our forebears to build all the roads and the structures around Verona, probably. I thought I'd show this especially because of this plaque. Do any of you know this rock that's on the beach? It says, in honor of the Matz family, pioneers of Verona, from their descendants. So we were just talking about the Matz house. The original Badger Mill, I think, was run by the Matz, wasn't it? Or
The mill wasn't, but the other farm across the street.
yeah, so the Matz were involved with it, or right next to it, or something. Yeah. So anyway, their house and the Badger Mill was down here. And so, anybody know what kind of boulder this is? Glacial erratic, yeah. So these are prominent boulders, and people like to put plaques on them because they stand out pretty well. What's that? They last a long time. They'll be there for 10,000 years. Yeah. So Proglacial Lake. Pro just means in front of, not that it's in favor of something, but it's in front of it. So as the glacier melted, often large bodies of water would form in front of it at the edge of the ice. The reason the water sat there is because the drainage patterns were all altered by the ice moving across them, and the ice often would dam up the lakes. As the ice melted back and ebbed and flowed, the lakes would sometimes suddenly drain, and all of the water would come out of them in a big hurry. Glacial Lake, Wisconsin, which covered half of the state, is what drained and is thought to have formed the dells. So the glacier came draped across the Wisconsin River drainage, stopped it and backed it up fully enough that the lake filled half of the state above that. And it used to drain out through Black River, or the Black River, down into the Mississippi, so it drained backwards. When the ice melted back, it opened it back up the channel to the Wisconsin River, and that whole lake drained catastrophically and basically washed out all those sand and gravel bars that you now see in the Wisconsin River if you go boating on them. That's all sand from the Dells area that got carved out, in a week, or maybe several weeks when it happened over and over again. Did that happen in Verona? Maybe. So here's a proglacial lake in Greenland. This is the big glacier. Here's the melting water, and it's trapped by this ridge that's here with another lake behind it. So where was the lake in Verona? Here's the same picture of the glacier. That's where I think the lake was. And if you look back, you can see kind of a bowl like this. And there's still water there. So this is Epig is right here up on the higher area. This is the big gravel pit that's there. This is along Northern Lights and Nine Mound Road. And then this is Shady Oak Lane, so that's the edge of the glacier right there. And then here's where Doug lives up here. So that's, if you just look at it, it looks like a big lake bowl. Now, where did it drain? I'm going to point your attention to right here is a channel, and then it opens up to a big wide area, and this is the Sugar River Valley down here. So does anyone recognize this channel that's here? It's like right on the edge of Nine Mound. There's a little trail called the Verona Trail on it. And I noticed this when I first moved here like 30 years ago. It's used to be on the edge of town. The town's gotten bigger since then, but it's this 50-foot deep by maybe 150 feet wide channel that's rounded out, and it looks like somebody constructed it, like ran a couple of bulldozers down it and just pushed all the dirt out of the way. And it's now filled with big old oak trees, and someone's put a hiking trail down through there. But I just looked at it and said, now what is that? Like, you know, what's that doing there? And so my feeling is this lake formed, the ice dammed it all up, and then at some point the ice melted back and it all came right out down that channel. So now the lake is dry and all the water flowed down. This is my attempt at animation. I'm getting better, yeah. And so all the water came out here and flushed down the Sugar River Valley. Now, I looked this up in as many geologic references as I could find. I don't see it anywhere, and so may not be what happened, but it sure is a good story, isn't it? Thank you.
You need first author on that one.
All right, yeah, I'll claim that. There's probably some reason why it didn't really happen. So this is the same view right by, just north of Epic, right by the big gravel pit that's still there. This is the terminal moraine along Shady Oak. And there's a driving range right over here that someone's put in, and this is somebody's big farm. And if you look at that, it's just flat as a lake bed. It's just this huge big bowl that's out there. And I think that's the old glacial Lake Verona. Here's the beginning of that channel right by Epic. And it actually gets much deeper, but it was harder to photograph because there's private property and there's trees growing in it and a lot of honeysuckle. This is all honeysuckle bushes all along it. But basically, this is the channel, just the beginnings of it. Further down, it actually gets narrower and deeper, so it's more like this. And I think that's where all that water went out. If you look at the grass that's even in it right now, at some point, melting snow and ice still flowed down it from the winter melt-off or one of the heavy rains we had this spring. All right, so last thing we're going to talk about is tunnel channels. A tunnel channel is an unusual structure that's at the edge of a glacier. It's under the ice, and it's a channel that discharges large amount of water as the glacier melts. How do they form? It's because the glacier's edge is colder than the bottom of the glacier and is frozen to the ground. So the edge of the glacier is hitting minus 20-degree temperatures that are outside the edge of the ice. Underneath the glacier, 500 feet deep, it's actually a lot warmer than it is at the edge. There's pressure and there's heat developed as the glacier scrapes across the ground. And so it's enough to bring it up sometimes to 35 or 40. The water will melt and will start to collect underneath it. And it's actually thought that's part of what lubricates the movement of glaciers is there's liquid water under it. If enough will develop, it gets under a lot of pressure and it's warmer than the rest of the ice, so it will more or less drill its way out from under the glacier and go out towards the edge. And then when it hits there, it's just like a dam bursting. It'll discharge a lot of liquid water, sand, gravel, boulders, what have you. Here's a diagram of that forming. So here's ice, here's the tunnel with water on it, and there's debris underneath it. When the ice finally melts off, what's left is a channel like this. And geologists can tell a tunnel channel from a outwash channel. I'm not sure how, so if you want to ask me, go ahead. I'll just make something up. Here's a map of tunnel channels all statewide, and so the Ice Age Trail crosses many of these, but they're much more prominent up north for some reason to do with how the glacier melted back up there. So there's lots and lots of them up in Chippewa and western Wisconsin. Down here along the edge of the glacier there were some. Here we are in Dane County, there's precious few. Back here, again, are the drumlins that we're talking about that show the direction of flow of the glacier. And so it was thawed underneath enough to produce drumlins. At the edge is where these tunnel channels came. And so where was the one in Verona area? It came out through Elver Park. And I went up to try to take a picture of this yesterday, and it was actually just raining and blowing, and there was construction everywhere, and I never was able to find a good picture of it, so I don't have a photograph. But I think most of you that have lived here 30 years, you kind of know this area anyway. The Elver Park has some steep sides on it. There's a fairly narrow outlet of it towards Raymond Road and the five points area. And so a lot of water basically drained out from under the glacier when it was back here and ripped out right to the same area where this lake was that I was talking to you about, and the quarry and gravel pits that were here. So whether the tunnel channel formed all of this gravel that was then mined out to form those giant gravel pits, or the lake, or some combination, maybe all this water came out and then filled this area and then later drained down this way. You know, I'm not really sure, but that's why there's so much glacial debris and such a huge gravel pit right there. And you can see evidence of the tunnel channel if you look. It's just all these steep slopes alongside the roads and steep edges. If you've ever tried to sort of shortcut it to Westtown by driving through there and avoid the traffic on M, when you go up and down all those hills, that you're basically going across the tunnel channel on that route. All right, so that's the end of my talk. I finally got to the end. If you want to learn about Ice Age geology, Verona is a great place to learn, and you can go enjoy the Ice Age Trail at Moraine Kettles. And I always end with a sunset. So, questions?
Is the actual trail at the edge of the ice or someplace in the debris?
Yes. Yeah, so the question is, like, is the trail follow the exact edge of the ice, or is it in the debris? You wouldn't believe how hard it is to build a 1,000-mile-long trail, especially when you don't have the power to condemn land or grab land from people. So there's people think that the Ice Age Trail is a little bit like the Department of Transportation, where you can condemn people's land and say, you know, we're putting the trail on your property. It has to be a willing seller, because we don't have that power, and we don't really want to have it, because that would make people pissed off at us, just like they are at the DOT. So it's a long, arduous process to acquire land to get the trail to go in the corridor that we want. So,
Realize that you own it.
well, we don't. Actually, the Ice Age Trail, the land that the Ice Age Trail is on, some very, very small percentage of it is actually owned by the Ice Age Trail Alliance, like 1% or something like that. Much of it is on public land, county parks, county forests, state parks, you know, that kind of stuff. A little bit of it is National Park Service over by Cross Plains. But much of it, like maybe half, is on private land, where we've asked a landowner, can we put the trail on your property? And that's why I'm trying to portray it as a big thing, the National Scenic Trail. If the landowner says yes, then it is. And we try to get
an easement, or?
Yeah, and we get an easement. In the early days, they would just shake hands and then say thanks, and we'll walk on it. And then what happened is the landowner would get older and die. The inheritors of the land would say, what, there's a trail on this? We don't want a trail on here. And they would just suddenly say, no Ice Age Trail. And so we would lose a huge segment of it. And so nowadays we won't put trail down unless we have a legal easement that will last through that kind of stuff. And we're basically putting it wherever we can connect it up near the edge of the ice. As you can see, you don't have to be right on the moraine to interpret all these features. Like where we walk through Badger Mill Creek, that's back a bit from the edge of the moraine, but there's still plenty to see in there that's interesting and has Ice Age significance and stuff. So.
Cross Plains is outside there.
Yes, and
Right.
yeah, so Tom lives in Cross Plains. The glacier stopped before it got to Cross Plains. There's a huge section of trail, and the offices are west of that, so you get to hike in the driftless area some too. So.
There's actually a KNL file we can download to superimpose on Google Earth.
Oh yeah, that shows the whole trail. Yeah, so I should, for any of you who are tech savvy, it's iceagetrail.org is the website if you want to learn more about it. I should have brought brochures had I been thinking ahead, but iceagetrail.org, you can learn all about it, and there's interactive maps on there that'll show you where it goes and that kind of stuff.
When we were talking about the tunnel trail coming out of Elbert Park,
Yeah,
I think that was kind of went out right by where the Marty farm is, if you know where Marty Road is. That's where it left. That's where it left.
Oh, yes,
Elbert
yes.
Park. Before Elbert Park was there, Gammon Road went all the way to Raymond Road.
yeah,
And that little chute between the big hill, if you're looking north to the left, was the hill, and then Elbert Park where the ski hill, the sledding hill is. It
Yeah.
kind of went between those two hills.
yes, exactly. So the sledding hill at Albert Park is one side of the tunnel channel.
Right.
The Marty farm, if it's what I think you're thinking of, that's the road that everybody sort of zooms through to cut through to West Town. Or at least I do, I don't know about anybody else. And if you go right instead of going to West Town, if you turn right towards Albert Park, you're gonna go up this very steep hill before you then get back up to where Channel 3 is
Right.
located.
That used to be Gammon Road.
Okay, all right. Well, I didn't realize that, but that's basically the sides of the tunnel channel that we're talking about. So.
My question, so the
Yeah.
tunnel channel and the Verona Lake you showed, are those theoretical because based on what it looks like, or are they actually geologically studied those and they know that was tunnel channel, they know that was like, it's just kind of like, it's suggested because-
Yeah, so the tunnel channel is known to geologists and is in the books. In fact, I'm going to take a second and show you where I got a lot of this material from. There's this book called Geology of the Ice Age National Scenic Trail by Dave Michelson. He's a Madison resident and a UW geology professor. You can buy this on the Ice Age Trail website or from UW bookstore. He was a member of the Ice Age Trail board when I was, and I used to carpool with him up to meetings in Baraboo. And as I got interested in this, I would just pick his brain. I'd just sit there and say, what's that? Like, what's that hill over there? And how did that get there? And so when his book came out, I bought it and read up on everything and stuff. So the tunnel channel for Verona is in here, the Albert Park Tunnel Channel. Lake Verona, I discussed that with him at one point, and he sort of poo-pooed and said, well, we don't really have any evidence, and he's the real scientist, so he's not allowed to say that it's there. Whereas, I like slept in a Holiday Inn last night or something. I can say whatever I want because I just think it's interesting to think that it might have been there. So there's, when I was a doctor, I couldn't do this, but now that I'm a fake geologist. There's another book, if you want to get it. This is a little bit older. It's called Pleistocene Geology of Dane County. It's a real potboiler. Yeah, dry. It's by Lee Clayton and John Addig. They're older colleagues of Dave Michelson's. It comes with huge maps and all sorts of interesting tidbits. Several of the diagrams I showed you are from this book. And so this one's available through the University of Wisconsin Extension, Wisconsin Geological and Natural History Survey Bulletin. So you can get that, I think, through the UW bookstore too. Yeah.
Talk about joining the Ice Age Trail Alliance.
Sure, thank you, Doug. Huh. All right, we're a member organization for the Ice Age Trail Alliance. It's a $50 membership donation. You get that, write it off your taxes, although I guess they changed the tax code, so that's harder now. But it's basically $50 a year to become a member. Your money goes to a good cause of creating, supporting, and protecting the Ice Age Trail. If you're wondering why there's so many gaps and why don't you finish it all up, if you could give $50 a year, that would go a long way towards helping it. Right now, there's the annual meeting going on for the Ice Age Trail Alliance is up in Sheboygan this year, and it's going on this weekend. When I changed the talk from next week to this week for the convenience of my wife so she could attend, I forgot that I was missing the annual meeting as a result. So that's why there's not as many Ice Age Trail people here. They're all up in Sheboygan. I'm sure having a great time in the snow and rain and stuff. So it's a good one to miss. Yeah, so our symbol is, she wants to know about the signage of the trail. The symbol of the Ice Age Trail is a yellow blaze. All of the National Scenic Trails had different color blazes. I don't know what all 13 are. I hiked a lot on the Appalachian Trail, and I know that one's white. So I got used to looking for that. But the yellow blaze is the symbol of the Ice Age Trail. And so if you're following the yellow blazes, you're on the Ice Age Trail. The other thing you'll see is that pregnant triangle symbol with a mammoth in the middle of it. That's, we put that on a lot of junctions where it crosses roads or it hits some other trail or something like that. That's sort of the official logo of the Ice Age Trail. So yellow blaze or pregnant triangle picture.
Our town roads now have the sign because the Ice Age Trail community.
Yeah, so the Ice Age, thank you, the Ice Age Trail community that happened a year ago, we've started a new program where the Ice Age Trail is really unique among the National Scenic Trails, like the Pacific Crest Trail and the Appalachian Trail. You can walk for days and days and days, and you're nowhere near civilization. In fact, you have to plan as a thru hiker to get off the trail, to get to a town somehow, to get groceries, to get back on the trail or take a shower or something. With the Ice Age Trail, you can't walk more than a couple of hours without going through some community. And there are a number of communities along the trail that are very significant. Janesville is one where the trail goes right through it. Delavan, I think, is another one. Cross Plains is another one. And then Verona is another one with 7 miles of it. And so Verona became, I think it was the 7th Ice Age Trail community in the state with this ceremony and cutting the cake and stuff. And then we have signs up on all the entrances of town that has along with Kiwanis and the Optimist, there's something that says Ice Age Trail Community.
You get many people that actually camp along the trail in this area?
Yeah, well in this area, yeah, I think one of the shortages of the Ice Age Trail is the lack of good camping spots and water spots. Like the Appalachian Trail has huts all the way along it. Ice Age Trail, you have to be a little more stealth about your camping, but we've now started a program called Dispersed Camping, it's DCAs, Dispersed Camping Areas. And there's one in Verona. It's at Badger Prairie Park right by shelter number 1. A friend of mine and I put that in basically with a lawnmower. We just mowed out a section of the trail, or mowed out a section of the prairie, and that became the camping area. And then there's a bathroom nearby and water and that kind of stuff. So, and a town that you can go get groceries in. So yeah, there are people that thru hike the trail. The fastest anyone's ever done it is 61 days. There's a guy that lives out in Blue Mountains named Jason Dorgan, who's a long distance runner. He ran 60 miles a day.
Oh my God.
I'm sorry, let's see, 60 miles a day for 27 days, that's what it was. And that comes out to 1,200 miles. He had a support crew with massage therapists and stuff, and slept 5 hours a night or something, but he did it. I don't know what he saw when he did it. He went really fast. There's people that have hiked it in about a month. It was about the fastest anyone's hiked it, a month and a half maybe. But most people will take at least 2 or 3 months to do the whole thing. And a lot of people just hike in sections. They do a little bit here and a little bit there, and they take 11 years to hike the whole thing. So.
Dane County Airport, did the ice come through Dane County Airport and Oshkosh?
Well, the ice would have covered Dane County Airport. It didn't stop there or anything. So
because it looks like a lake, flat. And Oshkosh.
Well, yeah, I'm not sure exactly what's in the Dane County Airport area, but I know there's a lot of sand and gravel and stuff there. So the Four Lakes area of Madison, the Yahara River used to be a deep river valley. Like if you think of the Pecatonica out west in the Driftless area, the Yahara was probably much bigger than that. Think maybe like the Wisconsin River Valley down near the Mississippi, or the Mississippi itself. It was probably steep sides of 450 million year old sedimentary rock that the Wisconsin River was cutting through. When the glacier rolled across it at an angle, it basically filled the whole valley with debris and blocked up the river in a number of places, and that's where the lakes came from, because the glacier scraped across them. The airport is right by Lake Mendota, and there probably was just a lot of sand and debris that was left there, and maybe even a bigger lake that covered that area at one point. Like Mendota could have been much bigger when it was originally the glacier was sort of sitting right there. and so that formed a big lake bed, and that's what the airport is built on. The other place is Oshkosh, is that what you said?
Yes.
Well, that's associated with Lake Winnebago, which if you look at Green Bay, it's right in line with Green Bay, Lake Winnebago, and then down to here, that's the path of the glacier. So as the glacier scraped through Green Bay, it also carved out Lake Winnebago and left big flat areas. So all of the lakes that we now have in Wisconsin were much larger at the time of glaciation because there was so much more water around and such poorly formed drainage because the glacier just filled all of the drainage areas and stuff. They've now cut bigger channels, and so the lakes in eastern Wisconsin are still there. The drainage coming off of them is fairly shallow. Like think of the Rock River and the Crawfish River, I think you cross when you go to Milwaukee. They're fairly flat rivers that don't have a lot of current associated with them. Other questions? I'm finally figuring out the microphone, I think. Well, thank you very much for people coming.